Hello students, welcome to the microprocessor lecture series. In the today lecture, we will discuss about the program which is used to subtract the two 8-bit binary numbers. Okay. So first of all, we use two 8-bit numbers which is stored in the memory locations which will be given into the uh, program question, and we use some arithmetic instructions like sub with some register which will be subtract the content of that register from the accumulator. So these two 8-bit numbers which is stored in the memory, first we will move these contents into the accumulator and some other register of the microprocessor 8085, and then we will use some instruction like sub with the some register in which the second number is been placed, that will subtract the 8-bit content of the register from the accumulator. And according to the status of the carry flag which represents the borrow, there is a uh, condition if there is a borrow present or not. You know that if we subtract the greater number from the lesser one, then the borrow will be taken. That means the carry flag will be 1. If the carry flag is 1, then we need to take the 2's complement of the difference which is present into the accumulator after the subtraction process. If there is a no borrow, that means if the carry flag is not 1, that means the carry flag is 0, then there is no need to take the 2's complement of the subtrahend, and we directly store the content of the accumulator which is difference into the appropriate memory location. Okay, so we will use some algorithm to represent this subtraction process. I have taken the steps which is followed to subtract the two 8-bit numbers. In the first step, we start the program by loading the first data into the accumulator. That means the content which is stored in the memory will move into the accumulator using the direct addressing mode. To transfer the content from the memory through the direct addressing mode, we will use the instruction LDA with 16-bit address of the memory. Okay, the content which is placed in this 16-bit address will load into the accumulator. Now this is your first data. There is also a need of the second data which is also stored into the memory, so we move this content, this first byte of the content, into some other register, because we need to store to read the second data also from the memory. So using this instruction the accumulator should be available, but in the first step this is occupied, so we have to clear the content of the accumulator into some other register. We have to move the content of the accumulator into the some other register, so we will move the data of the accumulator into some B register. We will take other register also, uh, except B. We can take C register, D register, E register, H register and L register. These are some other registers. So by using the step 1, we write or read the another data from the memory into the accumulator, because this is the arithmetic function which will perform onto the two set of data. So that's why one content of the binary number is stored into the B register, and one number should be and must be stored into the accumulator, because these arithmetic and logical instruction perform on the accumulator. Okay, then we will use the some subtract instruction to subtract the two register contents. One is the accumulator and other is the B register. In this algorithm, if we take some other register except the B, so we will use some other register command also. Okay, so there is a possibility, there is a borrow or not. In the 8085 program, for the borrow we will use the carry flag. In the addition, this represented by the carry, and in the subtraction process, the same bit of the flag register, bit 0, represents the carry flag. If carry is present, which represents the accumulator content is lesser than the content of the B register in this case, so there will be a negative difference. Okay, so to convert this difference into the appropriate way, we have to take the 2's complement of the difference, which is stored into the accumulator after the step 4. By subtracting the content of the A register and the B register, the difference will be stored into the accumulator. Okay, so now we have to, if there is a borrow, we have to take the 1's complement of the accumulator and then add the 1, which is needs to take the 2's complement. It is a process. Okay, if there is a no borrow, then the difference is the actual difference, so we directly store the difference and the borrow into the destination memory location. So these are the steps which we will need to follow for the subtraction process of the two 8-bit numbers. So now we will move towards the assembly language program. In this program, we have used some C register. This C register is used for to store the borrow, the presence of the borrow if there is a 0 and the borrow is 1. Okay, so to store the borrow, the content of the C register should be 0, so we first initialize the C register to the 00H. That means we have to clear the content of the C register. Now the first data which is have stored into the 4150 memory location, we will need to move the content of the memory location into the accumulator, so we will use the instruction LDA 4150. This 4150 is the memory location at which the first byte of the subtrend is stored. Next, we need to move the content of the accumulator, which is get by the instruction 2 LDA, into the B register to clear the content of the A, by which we can read the another byte of the data. Okay, so in the fourth step, LDA 4151, we store the content of the 4151 memory location into the accumulator. Then here we get A, which holds the content of the 4151, and we has the B, which contains the data of the 4150 memory location. Then by using the instruction SUBB, because the other data is in the B register, so we have represent here the B, so SUB will subtract the accumulator content, so subtract the content of the B register from the accumulator. Okay, now we checks the condition there is a borrow or not. So borrow is there or not by checking the carry flag status. So if the carry is not come, so we use the jump instruction, jump if no carry. It is a conditional jump instruction. If there is no carry, we will move to the loop label, and this loop label holds the STA4152. That means after the instruction SUBB, the accumulator content holds the difference of the A and B contents. Then that difference will store into the 4152 memory location when there is no borrow. Okay, but if there is a borrow, that means the content of the accumulator is smaller than the content of the B register, and the results difference is the negative. So we have to take the 2's complement. For these 2 complement, we have to complement the accumulator content by using the CMA instruction, and then increment the accumulator by 1. And because these instruction works, so that means there is a borrow, so we have to increment the C register also, INR C. Okay, so after this process, the content of the accumulator has the 2's complement, and the content of the C register has the borrow only when this condition is false. That means there is a carry equals to 1, and this carry is also represented by borrow because there is a subtraction process. Okay, so after this step, the following steps are common if there is a carry or there is not carry. Okay, the STA 4152 stores the difference, and STA 4152 store the borrow. This borrow will need to store into the accumulator first, then by using the move A comma C, the content of the C register will move into the accumulator, and then we will store the content of the accumulator into the 4153 location. That means the location which is reserved for the borrow. So there is the terminate the program by using the HLT instruction. Okay, so if we take the example, here is the example. If there is an input which is 06 at 4150 location, so first one is move into the accumulator 06 according to the program, and now after the move B comma A instruction, this content will move into the B register. So now the content of the 06 has the B register has the content 06. Now after the second instruction STA 4251, the content of the accumulator has the 02. Okay, after the sub B instruction, the content of the B register, that means 06, will be subtracted from the accumulator. Okay, now there is a need of the borrow because the 2 is less than the 6, so we will need to take the borrow. Then this will become the 10, and this 10 gives the carry towards the 2, so there is 12, and we subtract the 12, we will subtract the 6 from the 12, then it will, what will be it, 12 के बाद क्या आएगा, 12 के बाद आएगा आपका 11 10 0F 0E 0D and this 0C. So that means the answer is 0C, and after the 10 जो इसने यहाँ पे बोरो दिया था, इसके बाद यहाँ पे क्या बचेगा F. So answer is FC. Okay, so answer is FC, and carry flag will be 1 because आपको 02 को बड़ा करने के लिए हमने यहाँ पे कैरी लिया था, इसलिए कैरी फ्लैग आपका 1 हो जाएगा. तो आपके इंस्ट्रक्शन में जंप इफ नो कैरी की कंडीशन आपकी फॉल्स हो गई बिकॉज देयर इज अ कैरी. सो हम क्या करेंगे, आपका जो एफ सी आया उसका वंस कॉम्प्लीमेंट लेंगे. एफ सी का मतलब क्या है, 1 1 1 1, दिस इज एफ, एंड सी का मतलब क्या है 13, ए का मतलब है 10, बी का मतलब है 11, सी का मतलब है 12, यानी कि 1 1 0 0. तो हमने पहले वंस कॉम्प्लीमेंट लिया, देन 0 0 0 0 एंड द 0 0 1 1, और इसमें हमने 1 ऐड कर दिया. ओके, सो 3 and 1 1 1 0 1 1 0 कैरी 1 इस 1 1 0 कैरी 1 एंड 1, यानी कि आपका क्या आएगा 0 4. इस कंटेंट में आपका पूरा का पूरा क्लियर कर देता हूँ मैं. द आंसर इज 0 4 and the carry flag is 1. I hope so you will understand the what is the subtraction process. So thank you to all, thank you for watching.